In a windowless lab, a research team fed a supercomputer millions of pixels from a 14-foot strip of linen and asked it a single question: could a human hand have made this? What came back was not a simple yes or no. It was a pattern, buried in the fibers, that none of the scientists on the project expected to see, and that none of them have been able to fully explain since. This is the story of the Shroud of Turin, the most examined object in the history of forensic science, and what happened when modern artificial intelligence was finally allowed to look at it. For most of its documented history, the Shroud of Turin has existed at the center of an argument that never seems to end. To millions of people, it is the burial cloth of Jesus Christ, bearing the faint front and back image of a crucified man along with bloodstains that appear to match the wounds described in the Gospels. To others, it is a masterwork of medieval craftsmanship, a relic manufactured to draw pilgrims and revenue to a church in 14th-century France. Both sides have spent decades marshalling scientists, historians, and statisticians to make their case. What almost no one anticipated is that the next major chapter in this argument would be written not by a theologian or an art historian, but by a neural network trained to spot patterns human eyes simply cannot see. Before we get to the machines, it helps to understand what makes this cloth so strange in the first place. The image on the shroud is not painted in any conventional sense. There is no visible brushwork, no built-up pigment, no binding medium of the kind used in tempera or oil painting. Under magnification, the coloration appears only on the very outermost layer of the linen fibers, a layer so thin that researchers have compared it to a stain of dust settling on a surface rather than a substance soaking into cloth. This detail alone has puzzled investigators since the cloth was first studied scientifically in the 20th century, because it rules out most of the obvious methods a forger of that era would have used. The most famous scientific investigation of the shroud took place in 1978, when a team of American scientists known as the Shroud of Turin Research Project, or STURP, was given unprecedented direct access to the cloth. Physicists, chemists, and imaging specialists from institutions including Los Alamos National Laboratory and the Jet Propulsion Laboratory spent 5 straight days running the shroud through the analytical tools available at the time. Their published conclusion was that the image was not formed by any pigment, dye, or paint that they could identify, and that the exact mechanism of image formation remained undetermined. That finding, printed in peer-reviewed journals, is still the most widely cited scientific statement on the subject, and it is one reason the mystery has never fully closed, regardless of what people believe about the cloth's origin. Roughly a decade after that investigation, in 1988, samples were taken from one corner of the cloth and sent to 3 laboratories for radiocarbon dating. The results pointed to a range between 1260 and 1390 CE, squarely within the medieval period, and the story was reported around the world as definitive proof of a forgery. For many people, that was the end of the conversation. But in the years since, that single test has come under sustained scrutiny from researchers on more than one side of the debate. Some chemists have argued that the sampled corner came from an area of the cloth that had been repaired or rewoven at some point in its history, meaning the carbon date may reflect newer repair threads rather than the original fabric. Other statisticians have pointed out inconsistencies between the results returned by the 3 separate labs that were larger than the official report initially acknowledged. None of this proves the cloth is ancient. It does mean that the 1988 test, contrary to its reputation, has not actually settled the question the way most people assume, and mainstream reporting on the shroud still tends to treat the carbon dating as the final word without mentioning that debate. This is the environment into which artificial intelligence has recently entered. Over the past several years, various independent researchers and a handful of academic teams have begun applying machine learning tools to the enormous archive of high-resolution images, spectral scans, and microscopic photographs that has built up around the shroud since 1978. These tools are not psychic or magical. What they are good at is exactly the kind of task human researchers struggle with: comparing millions of data points against enormous reference libraries and flagging statistical patterns that would take a human analyst a lifetime to notice by eye. One of the first things researchers asked these systems to do was something almost embarrassingly basic: compare the shroud image against a massive training set of medieval paintings, frescoes, and manuscript illustrations from the exact period the carbon dating points to. The idea was simple. If the shroud is a medieval forgery, its image should share underlying statistical fingerprints with other medieval artwork, the same way a forged banknote shares production fingerprints with the printing press that made it. According to researchers who have published on this comparison, the algorithms found no meaningful match. The brushstroke signatures, pigment distribution patterns, and surface textures that show up consistently across medieval religious art were absent from the shroud image. That does not prove supernatural origin. It is, however, a genuinely strange result for an object that is supposed to be a conventional painting from that era, and it is part of why the obvious medieval fake explanation has never fully satisfied the scientists who have spent the most time with the physical evidence. The second major area where computational analysis has produced a striking result involves the three-dimensional information embedded in the image. This part of the story actually predates modern AI. Back in 1976, two physicists named John Jackson and Eric Jumper fed a photograph of the shroud into a device called a VP8 image analyzer, a machine originally built to convert satellite photographs into topographic relief maps by reading brightness values as elevation data. Ordinary photographs, when run through this kind of device, produce distorted, meaningless noise, because a normal photo encodes lighting information, not distance information. When the shroud image was processed the same way, it produced a coherent, undistorted three-dimensional relief of a human form. In other words, the brightness of the image at any given point appears to correlate with how far that part of the cloth would have been from an underlying body, which is not how light and shadow behave in a painting. Recent computational reanalysis using modern imaging software has reportedly reproduced and refined this same finding with far greater precision than the 1970s equipment allowed, and researchers still cannot point to a known artistic or photographic method from any era that naturally encodes distance data into a two-dimensional image in this way. A third pattern that has drawn attention involves the relationship between the bloodstains and the body image itself. Under magnification and multispectral imaging, researchers have observed that in areas where blood is present on the cloth, the fainter body image does not appear underneath it. The implication, if the observation holds up, is that the blood was on the cloth before the image formed, and that whatever process created the image did not affect the fibers that were already coated in blood. This sequencing is the reverse of how a painter would typically work. An artist creating a devotional image would normally lay in the figure first and add blood detail afterward for dramatic effect, not the other way around. If the underlying observation is accurate, it is a difficult detail to explain through deliberate forgery, since it would require a medieval artist to apply blood in precise anatomical locations first, and then somehow generate a photographic quality image around it without leaving any trace of pigment. It is worth pausing here to be honest about where the evidence is solid and where it becomes more speculative, because the shroud has attracted no shortage of exaggerated claims over the decades, and a responsible look at this topic should not add to that pile. The blood testing conducted in 1978, and in later independent studies did identify what appears to be human blood, of type AB, along with elevated bilirubin levels, a compound associated with the kind of severe physical trauma described in accounts of scourging and crucifixion. That chemistry is documented in peer-reviewed literature. What remains genuinely unresolved, and is disputed even among researchers sympathetic to the cloth's authenticity, is the exact physical or chemical mechanism that created the body image itself. Suggestions have ranged from a burst of radiant energy to unusual chemical reactions between the cloth and decomposition gases to processes nobody has proposed yet. None of these explanations has been demonstrated in a laboratory to reproduce every characteristic of the shroud simultaneously, and viewers should treat any claim that this mystery has been definitively solved, in either direction, with healthy skepticism. There is a similar need for caution around some of the more dramatic anatomical claims that circulate about the shroud, such as the observation that the image shows wounds at the wrists rather than the palms, which lines up with modern forensic understanding of how crucifixion victims were actually restrained, in contrast to most medieval religious art, which conventionally depicted nails through the palms. This detail is real and is documented in the anatomical literature on the shroud. But claims about exactly what a medieval artist could or could not have known about crucifixion mechanics are harder to verify with certainty, since we cannot fully reconstruct the medical and anatomical knowledge available to every artisan working 800 years ago. The honest version of this story treats it as a genuinely interesting anomaly worth investigating further, not as an open and shut case. The same caution applies to the Sudarium of Oviedo, a separate blood-stained cloth kept in a cathedral in Spain with a documented history that researchers trace back many centuries, independent of the shroud's own history. Some researchers have compared the wound and bloodstain patterns on the Sudarium with those on the shroud's face and reported apparent correspondences in blood type and wound placement. Other researchers dispute how precise those correspondences really are once you account for the different conditions each cloth was found in. It is a genuinely interesting line of investigation, not a settled proof, and it deserves to be presented that way. So where does that leave the actual AI findings? The honest summary is this: modern computational analysis has not proven that the Shroud of Turin is the burial cloth of a first-century crucifixion victim, and no legitimate researcher on either side of this debate claims that it has. What the recent machine learning work has done is sharpen several long-standing anomalies that traditional research first flagged decades ago. It has strengthened the observation that the image does not match the statistical fingerprint of medieval painting techniques. It has reinforced the odd three-dimensional distance encoding first noticed with the VP8 analyzer in the 1970s. And it has added new precision to the question of sequencing between the blood and the image, an observation that remains difficult to reconcile with the theory of a straightforward painted forgery. At the same time, the 1988 carbon dating controversy remains genuinely unresolved rather than debunked, and the exact mechanism of image formation remains, by the admission of scientists on every side of this debate, unknown. What makes the Shroud of Turin such an enduring subject, nearly a century after the first rigorous scientific studies began, and now well into the era of artificial intelligence, is that it refuses to fit neatly into either camp. It is not a case where the evidence obviously points to a clever medieval hoax, and stubborn believers are ignoring the facts. It is also not a case where the evidence obviously proves a miraculous first-century origin, and skeptics are simply in denial. It sits in a genuinely uncomfortable middle ground, a physical object that has been poked, scanned, dated, chemically tested, and now algorithmically analyzed more thoroughly than almost anything else in the history of religious relics, and which still, after all of that effort, has not given up a complete explanation. Perhaps that is the real lesson of feeding the shroud into a neural network. We built these systems to find patterns that our own eyes and intuitions miss, hoping they might finally close the book on one of history's oldest arguments. Instead, the machines mostly did what good scientific instruments have always done with this particular piece of cloth: they sharpened the mystery instead of erasing it. The Shroud of Turin remains what it has been for as long as people have studied it seriously, an object that keeps asking harder questions than any single test, however sophisticated, has yet been able to answer. Whether the next generation of AI tools eventually cracks that mystery, or simply adds another layer to it, is a question that, for now, remains as open as it was the day the first scientists walked into that room in 1978 to take a closer look.